So we're going to zoom in on just adding integers. Take a minute to digest it. And I want you to see what patterns you notice for yourself. We're going to start with integer chips, apply it to number lines, and then make a rule together. So you've already taken notes. I want you to use this to help make sense of them. So integer chips, we know, are the little circles. You used the website. They were yellow and red. I have white and red. Red is still negative. White is positive. So we're going to do a few problems with them and see if we notice any patterns. -4 plus -2. So I have 4 negatives. And I'm going to combine them with 2 negatives equals, well, I can combine them because they're all like terms. They're all the same color. It's like having 4 apples plus 2 apples. I have 6. So my answer is, I have 6 red, so that's a -6. This is what it would look like if you drew it. Same on the bottom. +4 plus +2. I have 4 positive chips. I'll just flip them. Okay. I have 2 more positive chips. And it's like having 4 bananas plus 2 bananas. They're all the same thing. I have 6 positives. Okay, and that's the same as what you've always been doing. You've always added and subtracted positive numbers. Now we're adding negatives, and I want you to see what kind of rules you can make. So far, we have a -6, a +6. Let's see if we get the same thing again. Now we have 4 negatives and 2 positives. Okay, like in the video, you learned about 0 pairs because a negative plus a positive puts you right back at 0. They cancel each other out. I can make 2 0 pairs. I'm out of positives, and what I have left are 2 negatives. So -4 plus +2 is -2. Okay? If you're drawing them, if you need to draw them, do it. I suggest using your rules always because drawing a million little circles is going to take forever. But if I have 4 positives and I'm adding 2 negatives, I can't combine them. They're not the same thing. It's not like adding all reds together. I have whites and reds. I need to make my 0 pairs, and I have 2 positives left. Yep. Interesting. The left side has 6s, the right side has 2s. But on each set, one's negative and one's positive. So I want you to start thinking about what kind of patterns went on here. What was the same about these numbers to get 6? What was the same thing about these numbers to get 2s? And then the difference. How did we end up with the signs that we got? Okay, let's apply it to number lines. All right, we're going to do the same thing, different numbers. So I have +5 plus +3. So I'm going to start at 5. Plus means I'm going to go to the right. And this is the amount of spaces, +3. Or I'm going to face the right, and +3 tells me I'm going to move 3 to the right. 1, 2, 3, towards the positive side. Okay, and I end up with +8. Looking at -5 plus -3, remember this is where we start. We're going to start at -5. This is which direction we face. I'm going to face the positives because we're adding. And then -3 is the direction I move. So I'm going to move backwards because it's a negative. So I'm going to moonwalk back 1, 2, 3. And I end up at -8. Okay, interesting. Same number, different signs again. It makes sense because we always knew that positive plus positive is a positive. So why do you think negatives plus negatives are negative? Okay. Now we're going to mix it up a little bit. -5, so that's where I start, plus, face the right, +3. So I'm going to walk forward because I have a positive. 1, 2, 3. And I got -2. All right, this time I'm going to start at +5. I'm adding, so I'll face the right, the positive side again. And it's -3, so I'm going to moonwalk backwards. 1, 2, 3. So if you are adding a positive, you go to the right. If you're adding a negative, negatives take you backwards. Okay, and I ended up at +2. So again, different numbers on both sides, and each one has one of each sign. Okay. Do you see what all of the left side problems have in common? Every problem on this left side The numbers have the same signs. Okay? This number is a negative and a negative, positive and a positive, positive and a positive, negative and a negative. These problems are adding the same signs. Okay? To the right, do you see what they have in common now? Different signs in each problem. Okay, so I have -4, +2, positive plus negative, negative plus positive, positive plus negative. Okay? So that's why we have different numbers. 6 is up here, 2 is up here. But I want you to think about how we got different signs. We already said that we have a negative because they're both negatives. So when I add numbers with the same sign, okay, you just add your numbers. 2 and 4 make 6. Add the numbers. And then how do we determine the sign? Both of these are negative, so it came out negative. Both of these are positive, so it came out positive. Add the numbers and keep the same sign. All right, so that's our first rule. Okay, numbers with different signs. Let's see. 4 and 2, 4 plus 2 is 6, but I got 2. Normally, to get 2 out of these numbers, what would you have to do with 4 and 2? You'd have to subtract them. Okay, same thing. What would you have to do with 5 and 3 normally to get a 2? You'd have to subtract them. So if you have different signs that you're adding, you're actually going to subtract them. Kind of like our whole dividing fractions, we actually did the opposite and multiplied. Here, it's more of a difference of what direction you're moving. So you'll actually subtract, okay? And how do you determine how you pick your sign? Up here, I ended up with a negative. Down here, I ended up with a positive. Why do you think that is? Spoiler alert, it's not because it's just the sign of the first number. Okay? That's not what this is. All right, if you haven't thought of it by now, it's because 4 is biggest. Okay? And in this case, 5 is biggest, so we kept the sign. If it's biggest and you're moving the other direction, I don't have enough to get out of my negatives. I'm still in my negative zone on my number line. Okay? So if you're adding numbers with different signs, you subtract and then keep the sign of the larger number. You already have this in your notes. I hope it makes more sense. Okay, we're going to practice these rules on a little bit bigger numbers. So if I have -25 plus +12, different signs, okay? So I'm going to subtract them. So 25 minus 12. 5 minus 2 is 3. 2 minus 1 is 1. Okay, I subtracted. I choose my sign by keeping the one of the larger number. Okay? So this is a -13. All right. Same on the right. These are even bigger. There's no way I would put these on integer chips or count 125 places on a number line. But we know our rules. So we have different signs, so I'm going to subtract. 300 minus 125. Okay, if you don't remember subtraction, remember you have to borrow. My 0 can't take 5 out of it. Okay, so I'm going to borrow. My 0 doesn't have anything to give, so I'm going to go all the way to my 3. This is now a 2, and this is now a 10. But I'm borrowing, remember? So now it's a 9, and now this is a 10. 10 minus 5 is 5. 9 minus 2 is 7, and 2 minus 1 is 1. Okay, my largest number, let me correct something. So I know the largest number, you might have thought 12 is larger than 25. It is. Largest number, largest absolute value. I didn't have that up here. It's the number with the largest absolute value, not just the biggest number, the biggest absolute value. That means their distance from 0. Okay, -25 is farther away from 0 than 12. 300 is farther away from 0 than 125. So this would be positive 175. Because even if I started at 300, I paid somebody 125 bucks, so I lost it, I'd still be in the positive. I'd still have money left. Okay?